It's time for Pure Performance.
Get your stopwatches ready. It's time for Pure Performance with Andy Grabner and Brian Wilson. Hello, and welcome to another episode of Pure Performance. My name is Brian Wilson, and with me as always I have Andy Grabner. Hello, Andy. How are you doing today?
Hey, Brian. I'm pretty good. I'm just a little shocked about the snowflakes out there, and it is end of April. I think it's just stopped, but we are actually recording out of Denver, Colorado, right? Your hometown?
Downtown Denver. We're recording live in Denver, Colorado.
It's amazing, yeah.
We're always recording live, though, aren't we?
Of
course. Yeah, we're at a hotel in downtown Denver. Andy's in town for what are you in town for? I know this is going to be past already when our loyal followers listen to this, but just in case they're interested in what the topic is that you are going to be addressing tonight, what is it that you're doing here in Denver?
Well, besides salsa dancing, what I did last night, I actually go to a meetup tonight. I'm presenting at the Pivotal Cloud Foundry meetup, and I'm talking about metrics-driven continuous delivery. So basically baking performance metrics into the pipeline so that people that actually deliver software and run it on Pivotal Cloud Foundry don't just, run their apps and they're totally getting crazy with performance problems. So yeah, it's about performance, but metrics driven. That's what I'm here for.
Yes, you're always about performance. So Cloud Foundry is really cool stuff. I'm just starting to get into it a little bit too. So, but unfortunately, I cannot be there. It is my daughter's 5th birthday today. So happy birthday, Vivian!
Happy birthday!
Yay! So today we have a fun show. It's probably going to be one in a series of shows about top Java performance problems and problem patterns. Did I say that right? You had a better title, I believe, didn't you?
I think, top performance problems in Java or something like that. And as you said, probably going to be a series because there's just so many of these problem patterns, and we've been talking about them for years and years, and that's also why our customers, I would say, and the users of Dynatrace, they keep bringing us these examples of extremely bad problems that happen in the Java enterprise apps.
Right, and so we're going to attempt to cover CPU hotspots, some memory patterns and problems, and if we have time, we will get on to the top database problems. You might have heard or seen some stuff about the database, but it's a very important topic and one that we definitely want to tackle. If we don't get to database today, though, we will definitely get into it in the next one, and there's plenty more that we're going to cover in future Java performance problem episodes. But before we start, one thing, people can contact us at several ways. You can contact us. You can send an email to pureperformance@dynatrace.com. That's PUREPERFORMANCE at dynatrace.com. Also, my Twitter handle is Emperor Wilson, so EMPERORWILSON. And Andy, what's your Twitter?
My Twitter handle is Grabner Andy, so it's GRABNERANDI.
Yes, not Y-A-N-D-I.
Exactly, that's what I mean. And without any other ways, I think people can probably tweet and should follow the Dynatrace handle.
That one too, yes.
Yeah.
So it's just at Dynatrace, DYNATRACE.
Exactly, and I think the Twitter handle for Pure Performance is taken, but we could obviously use a hashtag. So feel free to use the hashtag #PurePerformance if you have any questions, and we'll follow that too.
Right, and probably the best way to do general would be tweeting over to Dynatrace, #PurePerformance.
Yep.
And that's it. So anything else you wanted to bring up before we start?
No, I think let's get started. Huh? Oh, yeah, actually, thank you. It's awesome is that we sit in the same room and you keep reminding me about stuff. Actually, and that's actually the segue over to getting started. A lot of the problems that we see and the reason why we can talk about it and write about it and speak smart about it is because a lot of our people out there use Dynatrace, but not only the paid version of Dynatrace, but also the free trial. So I'm promoting the free trial because I run the free trial program. So if you ever want to test the stuff out that we are doing and talking about, just go online and search for the Dynatrace free trial, register for it. You get 30-day free trial, and then the cool thing is it converts over to a personal license, means you can keep using Dynatrace full product, full feature on the apps that run on your local machine. So perfect for developers to do the sanity checks, perfect for testers, I would say as well. If you're testing some apps on a machine, install Dynatrace on it, and then you get all these cool things, and you can actually identify, and now the segue over too, and Segway is actually fun because my first company I worked for was also called Segway Software. So let's segue over to the top performance problems, and I would say, to make the link now back to the Dynatrace free trial and personal license, most problems that I've been talking about and writing about actually came in from people that leverage the fact that I have a program that is called Share Your Pure Path. So people can use Dynatrace, export the data, and then send it over to me. And Brian, believe it or not, Java is the number one technology I think that we still see out there. That's also why I guess we picked, at least from our customer perspective, right? They write a lot of apps.
Right.
And I got a total of 200 people last 12 months that sent me their data.
How many did you say?
200.
Okay, I thought you said 1,200.
1,200 would be a little excessive. Well, I would love to. But 200 people sent me their data in the last 12 months. And I analyzed them. And now I think I want to talk about like what we saw on the Java side.
Right. So we'll start with the CPU hotspots. And for everyone out there, obviously CPU hotspot is a hotspot in the CPU, but more importantly, there are many different kinds of ways you can have CPU hotspots, right? There are just general CPU consumption. We can be talking about synchronization issues and some weight issues, and well, why don't you go into starting with some of your favorites? I guess we'll let you. You see a lot more of this than I do.
Yeah. So the first thing I wanted to say, a lot of people say, well, for a CPU hotspot, I can just use my profiler. Why do I need another tool? And I agree with them, and I say, if you have a single tier app and you're a developer and you know how to use your profiling tools, that's great. But those people that may analyze performance don't have a profiler. They don't have the IDE where they can do all that stuff. So that's why they are going to tools like Dynatrace or other APM tools. And also if you have a distributed app, if you have one tier calling another tier, if you think about a microservice architecture or a service-oriented architecture, then you need to actually trace CPU hotspot from one tier to another tier. And that's why it's so nice to have more professional tools available. So when we talk about CPU hotspots, what I do when people share data with me, I open up the response time hotspot dashlet in Dynatrace. And as the name it says, it gives me the hotspots of the response time, and it actually breaks it down into what you said, Brian. The CPU, like which methods actually consume CPU. It also shows me synchronization time. It shows me wait time. So sync would be if code is actually syncing on each other, if you have sync blocks or synced methods, and they have to wait for each other to actually enter that block. Wait would be waiting on an object. And the fourth one would be I/O, which is also very interesting.
Right. And when you say waiting on an object, you're talking about a memory object or because the only reason I'm asking is that you said you use the word wait both with sync and wait.
Yeah.
Right. So let's just clarify that for everybody, because sometimes, especially when you're just looking at them initially, they could be a little confusing. Why is one wait and why is one sync?
Yeah, that's a very good question. So basically, synchronization is just, I would say, a language feature or a runtime feature where you can say, I have a piece of code that only one can enter at a particular point in time because it's dealing with some scarce resources or shared resources, and only one can have access to it. Waiting on an object is sometimes used for the same thing. So you can actually say, hey, I have an object, a Java object, and I'm waiting on it until anybody else notifies it. So it also can be used for synchronization. So I'm not able to pass that line of code until somebody notifies that object so that I can get past it. But it can also be used for other notification mechanisms. But typically they're very closely related, I would say.
Yeah, absolutely. And would you also, I know this one we're going to cover on the memory side, but would you say garbage collection can also be considered a CPU problem?
Oh, yeah.
It kind of straddles both worlds, right?
It does, because if you are too aggressive with memory allocation and the garbage collector needs to kick in all the time, that obviously means that you have higher CPU usage. In Dynatrace, we actually also show, and thanks for that.
This is kind of a shameless plug because it's one of my favorite features of our tool, and I don't mean to be plugging our tool, but heck, we work for them. But it's, with GC, when you're running GC, you're actually consuming CPU cycles to do that, right? And if you're not being able to see that specifically as GC from that kind of a breakdown, you might think it's just generic CPU consumption. Or you might have to cross-reference it to a GC activation chart and say, well, at the same time, there was some GC activity and there was high CPU here, so we can assume it was the CPU utilization was on that GC. But if your tool can actually show you this was actually GC and identify it as that, then that really just kind of breaks it out into a much clearer and easier to diagnose problem. Obviously, it's not an easier to diagnose problem because then you're dealing with a memory issue, and those kind of always get really sticky fast. So.
But let's quickly cycle back. So CPU hotspot. So I always go into the response time hotspot. I see in which layer of the app we actually have real CPU consumption, meaning methods are just cramping in the CPU. What I typically see is it's either methods that really have a bad algorithm implemented, strange loops, like just doing too much work. That's one thing. So you can actually drill down to the method level, figuring out which methods needs the CPU cycles. The other option, and what I see very often still, even though it's been years where we talked about this in the industries in general, is CPU hotspots related to string allocations and string manipulations. So I see still a lot of apps using string concatenations where they are building large strings, maybe even HTML pages or reports, and basically allocating on the one side a lot of memory because they're creating and attaching and appending strings. But it's also a lot of CPU that is consumed when string objects are copied over from one object to the other. So this is a big thing. So I typically find CPU problems when I look at methods that are somehow dealing with string manipulation. Regex would be another thing. Regex is another hot topic, regular expression,
And we're all pros on construct it. Well, you're actually really good at it, aren't you? One of our favorite things to do is construct a regular expression to capture something, and it's always a lot of fun.
Yeah, that's
someday I plan on mastering regular expressions and VI.
Oh,
through memory.
Yeah. So, but yeah, I mean, the advice that I give you, that I give people out there, because that's the way I do it. So I figure out, do we have a CPU hotspot? And it's a CPU hotspot in either my own code, in some of the methods, in some of the algorithms that I wrote, or is it related to things like string manipulation? Is it related to regular expressions? Is it related to manipulating some other types of objects? And typically, and that's the beauty of either a profiling tool or an APM tool like Dynatrace, it shows you down to the method how much CPU consumption that method has, especially in relation with everything else that is going on in the system.
Are there specific, this might be getting too specific, but are there any specific methods or at least classes that you would see as a dead giveaway that it is a string concatenation or just a string manipulation issue?
Well, it's obviously Java lang string, that's clear, right. And then it's I think it's the Java util regex. It's really the base classes. Yeah. The way you see it in Dynatrace, so if Java's lang string would show up as a problem, or if a method shows up as a problem, what you can also do is you can actually right-click on that method in Dynatrace and say, show me the source code. That's also beautiful because you don't have to be the developer and actually own and have the source code available, but because we have the bytecode available, we can just say, decompile the bytecode and show me the Java code, and so you can actually see, this is the reason, this is the loop where the method is actually going through thousands of iterations of doing string concatenations. Yeah,
and this is you talk about leveling up a whole bunch, right? That's and we all do that. That's a very common theme in the performance world of going out beyond just writing a script and running it and handing off results. What I love about these tools is it gives you that ability to start looking at the code behind it, right? And in the beginning, I had no idea what I was looking at. My code experience was when I was younger using BASIC, right? And I had to actually write 10, print Brian 20, go to 10, and run, and I get my name going down the screen, right? I also tried running. I don't know if you had them in Austria, but did you ever hear of something like a choose your own adventure book?
Where basically you flip between the pages depending on what you do. Yeah.
So I was trying to write one of those in BASIC, and I got to a point where I added a random element. It took me a while of going to the library, pulling out a book to see how to do the code, because again, this was all pre-internet. And once I conquered that, I got bored with it, so I gave up. But point being, right? I know it's a fun little sidetrack, but the point being is, the more you look under the hood, the more all this stuff is going to make sense to you, right? And this is how you level up. You start understanding what the code is. You start looking and seeing, oh, the CPU is running hot, and we see Java lang string. Now you know that problem is going to be with string manipulation. That then allows you to turn back to the development team or the architects or whoever you're in contact with to say, hey, it looks like we're running hot on the CPU because of string manipulation.
Yeah.
Which suddenly, bam, you just became a level 5 dwarf or a level 10 warrior or whatever.
And what I can tell you, though, I guess in most cases, development will come back and say, you know what, that's not my code. Damn it.
Yeah. They say there's nothing I can do about it. That's Java code. But that's when you have to look above it of what's accessing it.
Exactly. And what you actually, now it comes to my mind, what you'll see a lot, especially with string manipulations, is your classical XML parsers, your parser, any type of parsing framework,
right?
Whether it's XML, whether it is JSON. So these are all basically frameworks that make it easy for developers to actually consume content, but internally they do a lot of stuff. And so not that these frameworks are bad per se, from a CPU perspective, most of them are highly optimized, but still you can use it in a way that they end up having a lot of CPU overhead. So then it's a good argument and throwing it back to developers saying, well, here's two options for you. Either you go to the framework vendor, go to their website and see if there is a performance problem known, and maybe we need just upgrade to a new version, or learn how to better use their framework to actually overcome their problem, because maybe you're just calling the framework too often. Maybe you have not parameterized it correctly so that they can actually internally do some optimizations. All right, so that's...
I would love to see the look on a developer's face if I went back to them and suggested what they should do.
Well, honestly, but this is...
But it's great. This is the part of the unity, right?
Exactly.
Building the team, building the whole, the DevOps-y kind of feel of the company. And there's no reason, that anybody in the company should be a marketer. Somebody in marketing, if they happen to be very geeky and technical, should be able to bring that information to somebody.
Yeah. And you use the DevOps word. Ooh, we're really also getting into the mode of throwing that in all the time. I mean, which is true. Basically that's where the industry is going. Whether you call it DevOps or for me, it's like agile, right? I mean, or let's say that way. We are there to build better software, and we all have to step up a little bit and just look outside the box a little bit. That's what it is. Yeah.
Right. It's no longer pointing fingers and I have mine, you have yours, and I'll do my thing. Everybody kind of helps everybody out, and there's no blame.
So CPU again, to kind of sum it up, figure out which methods consume CPU. If it's not your own code, figure out who is making the call, and at somewhere up the chain, the executions chain, you will see your own code, and maybe it goes through a framework. Then figure out which framework it is, figure out if there's a newer version available, figure out if there's any documentation how to optimize performance in these frameworks. If it is your own code, then if you use Dynatrace, for instance, right-click, show me the source code. You'll figure out, it's a loop or it's something else. Show it to the developers. They will hopefully love you for that. And that's the way it is, right?
Right.
So I think that's it from a CPU perspective. So check out the response time hotspot. Check out the method hotspot. These are the dashlets that I love the most. And also what you should do, if you're running performance tests, I think you want to always figure out, does the CPU behavior change over time when you put different types of load on the system? Especially also if your application is dealing with different sets of data. So it could be that you never see a CPU problem because you're always testing against an empty database, but then you are testing against a prime database. Or if more people are on the system, and then your app is getting some additional data on the current activity, and you just have more data to process, then you actually see all these CPU hotspots. So not just do it on a sample database. But
right, we covered that a little bit. Was that the last?
I think so. I think that was probably the episode where we had Mark Tomlinson on the call.
Right. Good old Mark.
Yeah.
Marky Mark. Just make sure your testing environment is realistic.
Exactly. Yeah.
And that in itself is a whole different topic, right? But that can be difficult too. But you're not going to always see these problems if you're not testing with the right conditions. Yeah. And were there any, I know you're kind of saying this is the biggest thing with the CPU. We did mention synchronization and wait. Are there any big things on those sides, or is that a lot more individualized and a lot you're just looking out for?
Well, so what I'm looking out for, if somebody's testing an app, I think synchronization problems and waiting issues is something you cannot detect with a single user test, obviously.
Right.
So you have to have some load on the system, but you might be surprised just with 2 users, if you're using, let's say, if you have JMeter, right? If you have a nice script, then just crank it up with a couple of virtual users. Run them in parallel. It doesn't have to be a lot. Typically, you find basic synchronization problems with 2 or 5 concurrent users on the system, or simulating the same requests in parallel, the same request, and then watch out. And what I really love, what I typically do if I have the chance to run a load test, so I crank it up from 1 user to 5 to 10, 20 over a certain amount of time, and I watch the metrics over time. How much CPU do we consume? How much time do we spend in sync? How much time do we spend in wait? Because then I can immediately see if we actually have a synchronization or wait problem with increasing load. Because a perfectly scaling system will just consume more CPU in the same amount of traffic that is coming in. But if you see that you are shifting this over to actually more waiting and synchronization, you have this becomes a bottleneck, because the more people that come in, the more you're syncing. And that's basically then an architectural issue where you can say, hey guys, with 10 users, we already see 50% synchronization time. That means we have a serious problem here. So look at these measures. In Dynatrace, you can chart. I think we automatically spit out CPU, sync, wait, all this as measures. You can just chart it over time and just chart it while you run the load test.
Right, and in terms of the wait one, that one always gets a little bit fun, right? Because there's a couple different patterns. If you're in an asynchronous thread and you're in wait, that could be okay. It's asynchronous, and it could just be sitting there waiting for the next thing to pick it up and run with it. So when you're looking at those wait things, if it's in the synchronous part of the thread, that's when you definitely have some kind of an issue. But I've also found that waits can sometimes be fun to talk to developers about, because like, oh look, we got stuck in wait for 5 seconds, and sometimes their first response is, well, yeah, we have a 5-second timeout on the wait before it tries again. Yeah. Not understanding, no, but why are we waiting 5 seconds? What got us into the condition of waiting 5 seconds? So waits can be a little tricky to communicate as an issue to be dealt with, because people develop code for waits under certain conditions, so it doesn't break. But you really just want to get the message across that. But it's going to those wait states quite a lot now, whereas it wasn't under 1 user, 2 users. Now that we have that concurrent load. So it could be a little tricky. It
can be very tricky, especially, I think a lot of developers and architects use it as a way to handle, as you said, asynchronous activity, and you make an asynchronous call and then you wait, but basically you're blocking your current thread in the caller. So it would be much more efficient to go with an event-driven model, where you actually say, well, I'm doing my stuff, now I am triggering off an asynchronous call, but I'm freeing my own thread up for handling the next incoming request. And when my initial asynchronous call actually comes back in an event-driven system, I will then continue with the task that I have to do. But as you said, this is a much tougher discussion than saying fix it, because this typically means a total change in architecture.
Right.
But what I like, what you said is very good. In the very beginning, you said don't get always fooled by waits, because we see a lot of waits, especially when you are spawning in Java. Now, if you take in Tomcat or any other app servers, and you basically have incoming queues. So your threads that are waiting for picking something up, they will wait. So it's totally normal that they wait, because they have to wait for incoming traffic.
Correct.
So don't get fooled by that.
Yeah, I think seeing synchronization is a lot more of a red flag right away. Exactly. Then waits. You gotta, again, that's where the leveling up comes in, where you have to figure out what it's doing and why, and if there's a good reason for it, or if it's actually impacting the transactions itself and causing problems down the line. So it gets a little bit trickier, but that's when you take and send your peer paths to Andy.
Exactly. That's hopefully. But on the other side, really challenge the developers and show them, hey, we see with increasing load, we see wait here, and is this a wait intended or not? What you said with the timeout settings, right? We have a timeout setting, so we make the call. then we just wait for 5 seconds and then check is the response here. And then if not, then wait another 5 seconds. And that might be an approach that was good in the past, but if you cannot change the architecture, you should still think about, do we really wait for 5 seconds? Because maybe the response is already here after 100 milliseconds, so we are basically wasting 4.9 seconds. So you really need to figure out how to change these timeout settings. Maybe you want to make them much shorter, because if you know the response is on average here much faster, then you need to adapt your timeout settings for that.
Right. Why wait 5 seconds when you can go right away? Or, you know, if your timeout is 500 milliseconds, so then you go into 4 waits until it picks up. But that's fine. Yeah. It's better than 5 seconds still.
Yeah, exactly. And another thing that just comes to my mind, synchronizing wait settings on the different tiers, because typically, you know, you have tiers talking with each other, and you want to make sure that your timeout setting is the same as on the other side. So, for instance, if I call an external service and I give it 60 seconds timeout, but on the other side, the service that picks it up is automatically throwing an HTTP 500 anyway after 30 seconds if they're not done, just like maybe the default setting by the app server, then I need to sync it, because then I'm just waiting 30 additional seconds for something that I know is at the latest here after 30 seconds. So synchronizing the wait times and the timeouts.
Yes, but synchronizing used in a different way.
Exactly. Yeah, of course. Yeah, thanks for reminding me. I know it's not my first language.
So. No, I mean, it's the same. I would use the same word too. I think it's just separating it from a synchronization problem versus synchronizing, meaning like, hey, let's all synchronize our watches because we're going to go spy at the embassy and make sure we get the top secret documents.
Which embassy are we spying on this week?
What's the one? There was an old Peter Sellers movie called The Mouse That Roared. I forget the name of the fictional. If you haven't seen that movie, though, go see it. It's an old black and white Peter Sellers movie.
So was that before my time, I guess?
Did you ever hear the original Pink Panther moves?
Yeah.
So the guy who played the Pink Panther was Peter Sellers. He was also another great movie he was in was Dr. Strangelove.
Yeah.
It was a Stanley Kubrick movie. I was a film major before. So, anyway, yes, this is before my time too. These are all made before I was born.
So shall we reveal the age now? No.
That could be one of the. Well, I guess maybe anything else on CPU or no?
I think that's it. So just remember, check out the response time hotspot, the method hotspot. We show you CPU, I/O, sync, wait, and garbage collection too.
Right, and if your tool doesn't break it down that way, you could still figure this out. Just have to really look at what those methods are being invoked. It's going to take a little more intuition, but it's definitely something you can do or should be able to do with any kind of either profile or APM tool. But again, once you're into multi-nodes or microservices, you really want to kind of have some sort of APM tool in there to really give you that full vision. But speaking of the age thing, so we're going to introduce a new segment to our show. It's the trivia segment. And borrowing from Marvel Comics and the old days, they used to give out a NO prize for people who would catch inconsistencies in the storylines from different episodes. Ours is going to be the KNOW prize, where basically if you are the first person to get the answer correct by sending your answer to tweeting your answer to Dynatrace with hashtag pure performance and no prize. Although if you just get pure performance in there, I'm sure we'll pick it up. But try to get the two of them in there. We will put your name as the no prize winner on the episode on the site. So what we're going to try to do with these trivia questions, though, is make it so you can't just Google them. And even if you Google them.
Or Bing them, right?
You cannot use a search engine. You're very Bing friendly.
No, the reason why I am is because recently somebody pointed out to me, you always only mention Google. And it was a Microsoft person that said that.
Google's more of a verb at this point.
I know.
But point taken. You can use your favorite search engine.
Here we go.
Yes, web crawler. Basically, don't do that. Even if it is one you can search, please don't Google or please don't search it. Try to use your brain or make some fun guesses, because it'll be a lot more fun for everybody that way. And you're not really getting any real prize anyway, except for your name on a website, which I guess isn't that exciting.
Well, it is. Come on, it's a pure performance website. I mean, what's wrong with you?
Your name will be in the internet.
Exactly.
So, in the tradition of something that you cannot easily search, the inaugural trivia question of Pure Performance, ladies and gentlemen, maybe I'll see if I can get a drum roll sound effect. There we go. That's better than any drum roll sound effect I can possibly find. Is what is the first computer I, Brian Wilson, ever used? Now, I'm not talking about a calculator. I remember when I took a programming class in college, the professor was like, anything with a chip is a computer, technically. So I'm not talking about something like a calculator or a stopwatch, or a wristwatch. I mean actual computer that has a keyboard and, you can type stuff in on. So if you can figure out what that first one was that I used, then you'll get your name up there.
That's awesome. And I want to give the audience a hint, though.
Okay.
Because they should know, are you 20, are you 30, are you 40? I can see that your hair is already a little wider.
Oh, it's a lot white
than mine.
Yeah. So I am 42. Oh, you know what? That just ruined another question. Well, it didn't ruin another question. But bonus prize, and this is a real easy one, low-hanging fruit for any true geeks out there. Bonus prize is, what is 42? But the real prize is, what's the first computer I used?
Here we go.
Do you have any idea about what 42 is? Probably not.
I think I have an idea, but I don't want to spoil it. I don't want to give the audience the answer.
I just didn't know if you had any idea, if you were a true geek or not.
Yeah.
A true geek who, I guess you'd have to have very strong command and grown up with the English language, which you mostly have, I think.
Yeah.
Anyhow.
Right.
So that's it. So again, tweet your answer to @Dynatrace, #PurePerformance, #NoPrize, KNOWPRIZE. And the first one we get, we'll get their name. If we could use was it Flash or Blink tag from way back, we would do that, but they killed that one, unfortunately, long ago.
It was a great one. I remember it was one of my first websites I built.
Was it in GeoCities? GeoCities always had the best websites.
No, I remember when I was in high school and we built our first HTML pages. That was awesome. With the blinking text, and then we had the text. What was it called?
Scroll.
The banner, the scroll, Yep. It was awesome.
And all those great sites were usually built on GeoCities, and the page would load, and it would have some kind of maybe a dancing cat image, a drawn one, and there was a MIDI file playing some really bad music.
Yeah.
Those were the really good old days of the internet.
Yeah.
Anyway, so let's go into the next topic. So the next performance topic we're going to talk about is memory.
Yeah. So on the memory side, Java in general, memory is mysterious, I would say, and it's not that easy. There's a whole, I think, science about optimizing memory usage, garbage collection. I think we cannot go into every single detail. We should cover it a little bit. I think in general, there are two big things in memory. On the one side, it's obviously the classical memory leak, meaning memory is growing and growing and growing, and then the garbage collector tries to clear it up. But at some point, what happens?
It runs out.
It runs out. What happens? Yeah, it's awesome. So what happens when it runs out?
It crashes.
It crashes. So before it crashes, what happens?
Well, you'll see the CPU spinning up really high.
Yeah.
Everything will slow down tremendously, and everyone will be really mad.
And then typically
you'll get alerts, hopefully.
Exactly. Hopefully get alerts. So typically you get an out-of-memory exception. So Java tries to throw an out-of-memory exception, and then if it cannot really recover, then it just really crashes. And
before you go on, though, I do want to say, and we're not going to go into this at this point either, but you're talking about a memory leak. We're talking about a heap memory leak. Because there's also a native memory leak, which is
very good. Very,
very difficult. But we're not going to go there.
But it's also important in the Java world, because obviously not every code that runs in your Java app is Java code. And doesn't run within the JVM, but may load some native libraries and therefore is allocating native heap space. So that's why also in Dynatrace, when you do a memory dump, we actually show you how much heap memory do you have used and what's the overall memory consumption of the process. And basically the difference then is part of native memory. And then we actually show you how the native memory grows over time and whether you have a native memory leak, which could be you may have brought in some external library that is doing something natively, and they keep allocating memory, and therefore, you run out of memory. But let's go back to the Java heap space. So memory leaks is a classic one, and that basically what you do, you keep watching your memory counters. So for Java, you have the different heap spaces, right? What do we have, Brian?
Yes. Well, it depends on which Java you're using. Java, right?
Java.
Do you still say Java?
Java, yeah. I don't know.
Yes. A quick sidetrack. What always really impressed me about all the Dynatrace Team Europe was with English as a second language, they somehow picked up the Boston Java. Yeah. But anyway, what do we have? We have Perm. We have I'm blanking on this right now. We have
Eden.
Perm, Eden, Survivor,
Tenured.
Tenured. But
Yeah.
There's different ones with some different frameworks. They call them some
it
different
depends on
names
which
too.
JVM, right? It depends if it's the Oracle JVM, is it the IBM JVM, is it the SAP? There's different JVMs out there. They call it different, but basically it is heap generations.
Correct.
From young objects to old objects. And what you want to do, you want to monitor all of these heap spaces, and it's all exposed through JMX typically. That means you can see how much utilization do you have. You can also see how much garbage collection happens in each of these spaces. And if you basically see a constant growing of the survivor space, which is basically where objects end up if they cannot get cleared, and it reaches a certain level, and it reaches the top, and then garbage collection kicks in, and then it crashes, then you have a classic memory leak. Because typically what you should see if you don't have a memory leak is the classical, what's it called, the sawtooth?
I call it is it a sawtooth? Yeah.
It's a sawtooth pattern, right? So that's what you should, because basically memory grows. It grows because your application is allocating memory, and then the objects that are no longer needed eventually get garbage collected. So you should always come back to the bottom of the valley.
And garbage collection is fine. Garbage collection is necessary. You're never going to see no garbage collection, but you shouldn't see it running for so long that it's impacting your performance, right? So typically, you were talking about the survivor space. That's where memory goes. I don't want to say to die, but that's where it ends up when it's something that's used throughout for longer periods of time. Mm-hmm. But those garbage collections are usually have much more of an impact. Yeah. So you should be seeing a lot of, in a really good system, you might end up seeing a lot of GC invocations, but they're going to be in the Eden space, and they're going to be really short and fast, and they're not going to have that impact. Of course, by design, by the design of an application, the whole idea is as soon as an object is no longer needed, it should get dumped. Mm-hmm. Right. It's only when those objects are needed longer that they sit around longer, and they end up going into those into what tenured is after Eden,
exactly,
and then Survivor. But there always has to be a good reason for that. But that's where usually these problems come in, where people forget about these objects.
Yeah, and typically so watch out for them if the objects are promoted into the different higher regions, higher heap spaces, and then if it keeps growing and doesn't come down after the garbage collection run. So what are the typical things that I've seen is, and as you said, there's a good reason why objects are living up there, because you have caching frameworks that cache objects. That's why, and these objects stay there.
The in-memory cache.
Yeah,
right? And
exactly.
Oftentimes you'll see that building quite a lot during startup of the application, because it's got to load everything in, and you might see a quick ramp, but then again you should see it stabilize.
Exactly. But the thing is, if you have any configuration issues with that caching, that means if the caching strategy itself or the caching framework is never actually allowing very old objects to fall out of the cache, and not basically understanding that if it keeps putting more and more objects up there, that it's eventually crashing the system, that's a classical memory leak. So either buggy versions of caching frameworks, misconfigured versions where you don't have any expiring policies for these objects in the cache. Right. So this is then typically very, very interesting. How can you find out about it? You can take a memory dump. So you can either take a memory dump when you see, we're reaching that point, or if you're running in testing, you run some load, you see the memory going up, then take a memory dump. Another option would be wait for the system to crash. And if you have the chance, then the JVM actually takes a memory dump for you. That's one option. In Dynatrace, we also have the feature if an application crashes and we get the chance, then we actually capture the memory dump.
Right.
So, and then actually look at it and see, hey, which objects are out there? Because we actually see which objects are still on the heap, and then typically you find it's probably your own objects that are then referenced by one of these caching frameworks.
Right, and the other fun thing you see quite a lot of when you take a memory dump is a lot of string references, tying it back to the CPU, right?
Well, the reason why that is, obviously, is because if you look at an object, if you look at a business object,
Right.
let's say a person or an order, what is an order? An order is a set of values. And what are these values? They're either strings
Right.
or integers. So in the end, obviously, the most consuming part on the heap are going to be these primitive types, but they
Correct.
are referenced from these complex objects, business objects.
Right, and that's actually one of the tricky things about memory, at least in the beginning, is when you're looking at a memory dump, oftentimes your largest consumers of memory are going to be these placeholders for strings and integers and all these other components. So you might initially say, oh, it's a string issue, right? But it might not. It's usually not, because you're usually going to see quite a lot of that. You got to look a little bit down in the heap oftentimes, but there are quite often times when it is the string. So,
but the nice thing about this, what we try to solve, and I'm sure other memory profiling tools do the same thing, but we actually show you how much memory is referenced by these business objects. So we can actually tell you, well, the object itself doesn't have a whole lot of memory, but because it references 50 strings and 100 integers, the total garbage collection or the total memory it actually holds on to is X amount. And that's why I love the Dynatrace memory dashlet, where you can actually say, show me the objects that are responsible for keeping how much memory on the heap, and whether it's that object itself or the object it references.
Yeah, and I think another fun thing when you're taking a dump, and I haven't used a lot of memory tools outside of Dynatrace, so I don't know if this is common to a lot of them, but I love the concept of whether or not you trigger a garbage collection with the dump or not. Right, because that's going to at least, if you want to see, if you don't trigger, there's different reasons to do either one, right? And is this a common feature, or is this something that's just kind of...
I think I'm just the same way as you. We are so much used to Dynatrace because we have it available. Because once Dynatrace is in a Java app, you can just click a button and then we get the dump. I'm pretty sure that this is a feature that most tools have out there. And it's great. And it comes kind of to the second memory problem that people have. But let me just finalize on the memory leak. No, that's good. So the finalize on the memory leak. So figure out which objects are on the heap, which of them take most of the memory. Don't get fooled just by strings, as you said, Brian, correctly.
Yep.
And then walk back the referrer tree. So if you do a full memory dump, you can actually see who is referencing it, and then you will see, oh, okay, my business objects are holding a gigabyte of memory. And who is referencing them? Who is holding them who's holding them? And then you can typically step back all the way until you find a global array, a global something object that is holding on to it. And it typically has to do either with a framework that you're using, or maybe it was your developers that actually put stuff into these objects. Another good example are session objects. So if you have a web application, you keep on your user objects, your user sessions. And if you add more sessions or more data to the session, then these sessions grow and grow and grow over time. And these sessions are kept in memory by the application server, depending on the timeout setting you have for your user sessions. Typically, I think 30 minutes these days.
Yeah.
And that's why these objects grow and grow and eventually bring your application to crash.
And one thing you can do when you're looking at those as well is do a search on the memory or the caching mechanism. Like I remember looking at one about 2 years ago. It was HashMap, right? And I don't think I'm going to remember the exact component of it, but basically HashMap was meant to be used in one way, but it was very commonly used in another way to achieve another thing, just because it could do it, right? And people were like, hey, we can use HashMap to leverage this, and that's awesome. Hijack another framework to do something else if it's really efficient at it. But what I remember looking at when I looked it up, when I did a search engine look for it, was if you're going to use it for that alternate component, there's a major setting you have to change on it, because otherwise it's going to lock everything up and be allocating everything into long-term storage on it, right? And I believe in that case that was what it was, but again, I'm still not, I would never consider myself a memory expert, but at that time I knew even less. But just doing a quick search on seeing which, some of the identifiers that you're seeing in that heap, oftentimes can help point you to what maybe some of those common mistakes might be, to maybe not, here's the solution, everybody, but more of, here are some ideas we might want to consider to look at, just to help the rest of the team out with some ideas there.
I love that you mentioned hash maps. because basically hash maps, hash tables, and they're all collections, basically collection objects. And if you do a Dynatrace memory dump and you look at the memory dashlet on the bottom, remember the tabs that you see? We show you obviously the biggest objects, but then really focusing on the biggest collections, and then basically tell you exactly if you have a problem there. And I think we also show the biggest user objects, like session objects on an application server, and our favorite again, the strings. Yeah. Right, all the strings and the duplicated strings. That's crazy because the same string might be allocated 50,000 times and you don't even know about it because your frameworks are going like crazy. Yeah.
Yeah. So the second memory problem.
Yeah. So you mentioned the way you triggered it before, which you did pretty well. You were saying there's an option in Dynatrace where you can say, before I create a memory dump, I want to trigger the GC so that I basically see which objects are actually staying on the heap after the GC has done its work.
Correct.
So do you want to tell the audience what you think why we have this feature?
Yeah, so listen, if you're going to take a memory dump and not clean out your GC, especially if you're looking at overused consumption, right, or if your memory is pretty large at the time, right, if you take this is at least my point of view on it, if you take a memory dump and you don't run the GC on it, you don't know what was about to get cleared. So you're going to be looking at a lot of, potentially looking at a lot of extraneous objects in memory that have no impact on the problem of large memory consumption. So if you run that GC beforehand, you're going to be looking at everything that's stuck in the system that can't get cleared out, that is still being leveraged and utilized. And if you see something like, an order ID in survivor space, then you know very easily that you have an issue. But there are, the times when you not necessarily would want to trigger a GC, and I'm blanking on it now. I've explained this to people in the past, and I just can't. Help me out here. Why wouldn't you want to trigger?
Yeah. I'm seeing you chewing your teeth.
Yeah,
so basically, here's, I think, for me, the second thing. I totally agree with you what you said on why garbage collection. Now, the second thing why we actually see a lot of GC activity is if you have a high object churn rate, which means your application is actually allocating a lot of objects that are short-living. So that means you're allocating them, they live for a little while, and then get garbage collected. And they live for a while, and then get garbage collected. So in this case, I don't want to, in order to find out if we're allocating too many objects, even though they're garbage collected all the time, but if this is another problem pattern. So we can find out about it by creating memory dumps on a consecutive basis, but not triggering the GC, because we want to see how many objects of these very, maybe small, short-living objects do we have on the heap. And we do this over time, and then we can figure out, wow, we have this XML parser object, and we have 10,000 instances of it, coming and going, coming and going, coming and going. And it means, well, they're not a memory leak, but they mean that the garbage collector always has to clear a lot of objects.
Right.
And basically by knowing that, we can talk to the developers, hey, maybe instead of always allocating a new XML parser object, maybe you can reuse them. Maybe you create one XML parser object per thread, and then you solve at least concurrency issues. Instead of every time when a request comes in, creating a new instance of it that is very short-living.
Right, and this kind of points back to, I believe, the difference between having a memory leak versus the memory problem where your GC is too high.
Exactly.
And you can have excessive GC without a memory leak, and this is the exact kind of a case where that would be happening, where you're just putting way too many items that are going to get cleaned up into the system, and GC is just always running. And again, garbage collection is consuming your CPU. So if that's going too heavy, it's going to impact your code, and if you're not looking at the garbage collection, you'll be looking at your code. I've had developers, before I had, insight to garbage collection, saying, but this code is not doing anything with, string concatenations or string manipulations. This is not running anything on CPU, so why would I be, there's got to be something else hitting the CPU up high. And if you're not, again, thinking of garbage collection, you might make the mistake of first going to, what else is running on the box, right? But stick with the application first before you look outside, and you have to look at those garbage collection.
Yeah. And I think the technical term or the industry term is called object churning. So through how many objects does the GC churn through all the time, because you're allocating so many of them. So, and yeah, I mean, I think that's the two major things: memory leak and high object churn rate, which in both cases lead to garbage collection. But the one is more like the signal before the thing dies, right?
Yeah, think about it as your garbage can at home.
Yeah.
The memory leak is people keep putting stuff in the trash and no one wants to take the trash out, so it starts overflowing.
Yeah.
And then whoever puts the last piece in that overflows it gets in trouble, right?
Yeah.
And in this case, your app dies.
Yeah. Yeah. And the other one is basically we're just throwing everything out all the time, and then we constantly have to run. And basically it's a lot of overhead, so maybe we should throw less things away. I mean, creating less garbage.
I'm just going back to an example of at your home or apartment or something. I don't know why I'm going this route, but another idea popped in my head where you can think of the garbage collection without the memory issue is when you're taking a shower and someone else goes ahead and flushes the toilet. You have too much cold water being flushed away, and then you get burned and scalded because you just keep on dumping all the water down the faucet. All right, so here's our bringing it back.
How does your brain work?
That's amazing. You don't want to know how my brain works. No. I don't sometimes understand how my brain works.
So there's obviously there would be more stuff that we can talk about memory, but what I want to remind people, we have an excellent Java performance book online. I think
Correct.
If you Google for Java performance book Dynatrace, you will find it. And Michael Kopp, back in the years, 3-4 years ago, he wrote the chapter on memory and garbage collection, and he really did a phenomenal job explaining how memory is actually managed by the different JVMs, the different garbage collection options that you have, because we haven't even talked about different ways we can optimize the garbage collector as well. There's different...
Yeah, there's
modes.
a whole...
That's a whole science,
yeah.
right? So check it out. Check out the Java Performance book and look at the memory chapter. And also, we have blog posts on blog.dynatrace.com about real-life scenarios where our customers actually showed us how they found memory leaks in their different environments.
Right. And again, it's not just if you're, yes, we'd love for you to be using Dynatrace, but these are articles and ideas that are going to help you no matter what you're using, no matter where you're working. This is core stuff. Exactly. Right? And I'm glad you mentioned the Java Performance book, because that's actually where I first started reading in depth about memory. And probably the reason my mind was drawing such a blank is because I need to go back and review it some more.
And some of the stories, I remember one, a Oracle JDBC driver memory leak that brought the whole IBM WebSphere cluster down. And so these are the stories that we have out there and kind of showing how it works. We also I have a video on my YouTube channel where it says 15 minutes sanity check on memory on Java.
What's your YouTube channel?
My YouTube channel. Oh, it's so I have my bit.ly URL, so bit.ly/DT tutorials, all one word. DT is like in Dynatrace, DT and tutorials. Okay. And is that clear enough?
Yeah, DT tutorials. So bit.ly/DT tutorials.
That's awesome.
Because I don't mumble at all. So
no,
I do.
Oh,
I'm
okay.
joking. I mumble quite a lot. I try not to when I'm doing this. Yeah. But between your accent and my mumbling, I'm sure this is the...
I hope so. They figure it out, right? Yeah. Give it a couple of trial and errors. Yeah, but that's good. And remember, kind of maybe to remind people that we also have the Dynatrace free trial that you can download. So I'll say it once and then you repeat so that people really get it. bit.ly/DT personal. So that is
bit.ly, bit.ly/DT personal.
Exactly. So that basically brings you to the registration page for the Dynatrace free trial/personal license. We call it personal because it becomes personal after the 30 days. So register that.
And if you have any questions or feedback, you can always email us at pureperformance@dynatrace.com. If you wanted to follow, I'm not too active on Twitter, but slowly trying to become more. But I am Emperor Wilson, EMPEROR WILSON, and we have. What's that? I always forget yours.
It's okay. It's Grabner Andy. So it's GRABNERANDI.
Correct. That's on Twitter. And there's also, of course, Dynatrace on Twitter. And don't forget, if you know the answer to our trivia question today, what was the first computer I ever used? Remember to send that to @Dynatrace, #pureperformance, #NoPrize, KNOWPRIZE. And anything... We are just so the listeners have an understanding where we are. We are still in pre-production on all this. I like to give a little bit of the background just because, well, that's always been the stuff that fascinated me. These will all be soon very, very, very much going live, and we're very excited for that to be happening. So if you've been listening and following us, we thank you very, very much for that, and we'll continue to have a whole bunch of these coming out. We are up on Spreaker, and we also have a page on Dynatrace that's being worked on, so I cannot give out a URL quite yet, but I'm sure if you are listening to this and you search Dynatrace Pure Performance, it will come up in your favorite search engine.
Exactly. And I think from talking about Java performance, hotspots, performance problems, we have a long list. I think we did not get through the database.
Yeah, we did not get
to
to the database.
long. Yeah, but our database, web services, messaging, message queues, threads, pools, these are all topics that are very hot that we should cover in one of the upcoming.
Right, and if there's other ones that you're interested in, you'd like to hear some ideas on, please, communicate to us in any of those methods I mentioned before. Even general show ideas too. If there's something you find fascinating, like what cloud, how do you deal with cloud, or any other kind of topics that you think it would be good to hear more about, send us a note, and we'll, we have a lot of people we can pull in for a lot of great conversations. So we'd love to hear ideas from you. And
and what if people want to be on air with us?
Well, they have to get a broadcast license. Now, if you want to be on air, listen, if you have a great knowledge base or some great experiences, let's say you became the performance hero and tackled some amazing performance issue. It might have been one of these common ones, but you have a personal experience of how you went about doing it. If you have ideas and you'd like to be on air with us and talk, send us an email, pureperformance@dynatrace.com, and let us know what you're thinking, and we'll try to work that out.
And we promise that we don't make jokes about them, and we don't harass them, right? We promise to be good.
Yeah, unless we know you.
Of course.
If we know you, you're going to get harassed. But if we don't, we'll be very, very nice to you, and we will give you some virtual chocolates somehow. I don't know what that even means. There's my brain going in some way. Anyhow, we look forward to any feedback, any of the ideas or suggestions, and I will give you Andy, as he's logging into his laptop, any final thoughts before we sign off?
Any final thoughts? No, I hope the weather is getting better because it's really cold out there and we need to walk over to the meetup later. And other than that, I think just keep sending us these stories, especially me. Now, this is not my personal interest. Send me these Pure Paths. Use my Share Your Pure Path program. Share any other stories. If you are in the area where I am, follow me on Twitter. I typically post where I'm traveling to.
Right.
Look me up and just hunt me down. I'm always happy to share a beer and obviously a lot of stories with you, but a beer. Or find me on one of the dance floors. I typically go out salsa dancing in the cities. If you have any recommendations on salsa places in your city, let me know, and then we'll find an excuse that I get there.
Yeah, of course.
Yeah.
All right, well, thank you all very much. We'll see you next time. Goodbye.
Goodbye.